Alright, in this video I'm gonna correct the handout on the property of logarithm, okay? So here's the first 5 questions. They are all based on this given right here. The log base 5 of 10 is about 1.3, okay? And it asks you for log base 5 of 2, log base 5 of 0.25, okay. So the idea is to use this number right here, this number, 5 and 10, and with these two numbers, via multiplication, division, raising to a power, or taking the reciprocal, which actually amounts to raising to the power -1, okay, taking the reciprocal, via this operation to construct this number. So let me show you what that means, okay? I need to rewrite log base 5 of 2 differently. 2, I need to rewrite it with 5 or 10, or maybe a power of 5. I can use 25, okay? I can use 125, or I can use 100, okay? I can use the power of these numbers. As I said, you can raise to a power. But anyway, we don't need to do that. 2 is just 10 over 5. Why did I do that? Because now I'm going to use the property of logarithm that says that the log of a ratio is the difference of logs. Sorry. This is of 2 right here. And so that means, oh, where am I? Right here. This is of 5, right? The log base 5 of 10, well, that's actually, I need to use the squiggly sign right here, is about 1.43. And the log base 5 of 5, well, that's just 1, right? And so the answer is about 0.43. Okay, so now when I'm going to be looking at the numbers, 8.4, I also have a 2 that I can use to construct it, okay? Actually, I'm going to be using that right now. Log base 5 of 8, that is just log base 5 of 2 cubed. I told you, you can raise to a power, okay? You're allowed to raise to any power, to cube, to 5, to the power of root, whatever, any power is fine. Even power 1/2 is fine, okay? Anyway, so why did I do that? Because now again I'm applying another, oh, that's not a 2. I'm applying another properties of logs that says that the power can go down in front and multiply the log, okay? And the log base 5 of 2, where we just found it in the previous example, is 0.43. Therefore, this is 3 times 0.43, which is about 1.29. Okay, good. Let's keep on moving. Log of 0.25, well, for me, 0.25 is just the same as 1/4, right? 1/4, now I don't have a 4, right, but that's okay, because 1/4 I can use 2 to construct it. 4 is 2 squared, and now I'm gonna rewrite that as an exponential. This is not an exponential, right, but it can be written as an exponential, 2 to the -2, which then I'll take the -2 out, -2 times log base 5 of 2. Okay, and again, because we know log base 5 of 2, log base 5 of 2 is 0.43. This is just -0.86. Okay, all right. I hope it's not difficult. It's like a puzzle. 0.4. Well, 0.4. Well, listen, if you don't see that it is 2/5 right away, that's okay. Just use 0.4. That's 4 divided by 10, right? You move the decimal point, and now if you reduce that, you will see it's 2/5. So it's log base 5 of 2/5. Again, the log of a ratio is a difference of logs. Log base 5 of 2 minus log base 5 of 5. And the log base 5 of 2, we use that many times. It's 0.43 minus 1, okay? 0.43 minus 1 is about 0.57. Okay. All right, last one. So this is log base 5. Okay, I'm gonna take care of the cube root first. 4 to the 1/3. I don't know log base 5 of 4, right? I can take the 1/3 out, but I don't know the log base 5 of 4, so let me rewrite 4 as 2 squared to the 1/3. Now let's apply the rule of exponent. Okay, you multiply the exponent. So this is the log base 5 of 2 to the 2/3. And now let's take the exponent outside. 2/3 times log base 5 of 2. So it is about 2/3 times 0.43. So it is 0.86 divided by 3. I'm going to take my calculator. 0.86 divided by 3 is, yeah, 0.28666, is that it? It is, I should have used this right there, maybe, I don't know. 0.28666, okay? All right. Okay, done with the first problem. The second problem is actually very similar. Let me do something. Instead of... Ooh. Let me see. Right here, this one? This one should be thin, right? Oh my gosh. Something went definitely wrong here. Okay, come on, which one is thin one? Right here, right? What's going on? Why is it so thick? What about if I take this one? Is it going to be like hugely thick? Come on, there's something. Do you see that? Look, I'm taking the thinnest, right? This should be the thinnest, and it ain't the thinnest. Okay, let me take this one. Is that thinner? Okay. You know what? I'm not gonna circle tonight. I just don't feel like circling. All right. So this one? No, it's not. Okay. All right. The second problem, as I said, is very similar, except that they're giving you the log base 9 of 4, and they say that's x, and the log base 9 of 5, and they say that's y. Okay, so they don't write approximation. I shouldn't say they, because I'm the one who wrote the problem. I didn't write an approximation, I just wrote expression x and y. So this time you can use 9, 4, and 5 to deal with all your numbers. And because you can use 4, you can use the different powers of 4. That includes 2, right? 2 is 4 to the 1/2, right? Or 16 or whatever. And the different powers of 9, and that includes 3, okay? All right, let's start. Well, actually, we're going to have that right away. Log base 9 of 12. 12, so 12. I'm going to write it as log base 9 of 4 times 3. What can I do with that? Well, that's a log base 9 of 4 plus log base 9 of 3. Okay, 4, I know what it is. That's x. Now, the log base 9 of 3, I don't know that. That's not given, right? Still, I'm okay with 3, because 3 is a square root of 9. Here, let me write it. And of course, that's the first and last time I'm going to write it like that here. I don't care about square root. I want to write log base 9 of 9 to the 1/2, right? Now, there's a formula that tells you that log base a of a to the x is x, so this is just x plus 1/2. Actually, too close to the one at the bottom here. So it is just x plus 1/2. Okay? All right. Next one. Well, come on, that's going to be the same, right? This is going to be log base 9 of, did I put the 4 first or the 3? Yeah, 5 times 3. So you're going to break it, and that's it's going to come out to be y plus 1/2. Okay, if you're not sure, make sure you go over the detail. Come and see me if it's still not clear. 36, well, 36, I'm going to start by writing that as log base 9 of 9 times 4. Oh, that's pretty simple now, because this is a log base 9 of 9 plus the log base 9 of 4. And so it is 1 plus x. Okay, 1 plus x. 6.25. Did I miss any? No. This is the log base 9 of, I don't know what it is. It's 6 1/4, right? I don't like mixed fraction. I used it just to go back to the fraction. This is a log base 9 of 6 times 4 plus 1, 25 over 4. Now for that, I'm going to say this is a log base 9 of 25, that's 5 squared, minus log base 9 of 4. And the 5 square, the square goes outside, 2 times log base 9 of 5 minus log base 9 of 4. And so that is just going to be 2y minus x. Okay, good. Almost there, I think. 3.2. So this is log base 9 of 3 and 0.2 is 1/5, right? So it is a log base 9 of 3 times 5 plus 1, 16 over 5. Oh, come on, we just did this one. That's a log base 9 of 16, 4 squared, minus log base 9 of 5. So it is 2x minus y, right? Okay. Log base 9 of 6. Oh, wait. Earlier we didn't we look at 36? Yeah, right here. Look at that. The log base 9 of 36 is 1 plus x. Well, therefore, that's easy now. What is log base 9 of 6? How do you write 6 with a 36? That's easy, right? It's square root of 36. And so it is log base 9 of 36 to the 1/2. The 1/2 goes in front. 1/2 log base 9 of 36, which we computed before. So it's 1/2 of log base 9 of 36 is x plus 1, right? Yeah, 1 plus x. So it's 1, where am I? Right here. 1/2 of 1 plus x, okay? Which we would write 1 plus x over 2. Okay, all right, I'll finish this problem here and then I'll make another video for the other ones. Log base 9 of 40. So this is a log base 9 of 8 times 5. And I think we got log base 9 of 8, right? Didn't we get log base 9 of 8? Somewhere here. No. Maybe it was in the first problem. Yeah, possibly in the first problem. Okay, well, let's dig. So it is log base 9 of 2 cubed plus log base 9 of 5, and 2 is square root of 4. I forgot the 9. Log base 9 of square root of 4 cubed plus, let me write, this is y, right? We write y. And so it is a log base 9, square root, that's power 1/2, so it's 4 to the 3/2 plus y. And so it is 3/2 times log base 9 of 4 plus y. So it's 3/2 of x plus y. Wow, okay, so this one was a little bit more involved. Last one. This is the log base 9 of 4/10, so 2/5, right? So it's a log base 9 of 4, square root of 4, I mean. So it's 4 to the 1/2 minus log base 9 of 5. And so it is 1/2 of x minus y. And I have to stop the first video right here.